The derivative of any constant is always a 0. We can derive that using the 4-step process, but I'm not going to derive them. So what's the derivative? If you have y equals 7, and I said to you, can you tell me what is y sub prime? What's the derivative of that?
0.
0, yes. If you get y equals negative 3,000, what is the derivative of that? dy dx? 0. I'm trying to use a different notation of derivative. If we said f of x equals 48, what is the derivative of that? 0. Again, because you got y equals 7, that's a horizontal line. The slope of a horizontal line is 0. That's why the derivative of any constant is 0. It doesn't matter how big the constant or how small the constant. You take the derivative of that, it's always a 0. What's if you have y equals 4 pi squared? What's the derivative of that? Still 0, yes. Because pi is a number. 3.14, whatever, some fixed number. 22 over 7, whatever you want to use, 3.14. That's still a number. If I have f of x equals 6e to the 4, what's the derivative of that? That's still a 0. That's a number. There's no x in it. E to the 4 is some number. So you can do the math, find what that number, and take the derivative of that, which is a 0. That's a constant. So the derivative of any constant is 0. That's rule number 1. The second rule, the one I just used to do these problems in my head quickly, and I'll show you how quick it is. The derivative of x to the n. It's called the power rule. The derivative of x to the n, it's n times x to the n minus 1. So the derivative of x, where's my eraser? I guess I wasn't planning on making a mistake today. The derivative of x squared is what? 2x, yes. The derivative of x to the 50. Imagine if I gave you this and you have to do it the long way.
50x to the 49.
Yep, it's 50x to the power 49. The derivative of just x.
1.
Yes, that's a 1. Why? Because your power is really 1. So you move the power to the front and you subtract 1 from the power. What's 1 minus 1? 0. Anything to the 0 power is 1. You end up with 1. The derivative of the square root of x.
X to the 1/2.
Square root of x is x to what power?
So make 1/2 x.
1/2, yep. Change it to that first. Then you can apply this rule. I'm going to put a box around it. Since you have x raised to a power, you can use that rule, which says the answer is move the power to the front and subtract 1 from the power. 1/2 minus 1 is negative 1/2. I can clean that. I can make it 1/2 times 1 over x to the 1/2, which is what? 1 over 2 the square root of x. the derivative of 1 over x to the 5th. All of these, I'm using that rule there. As long as I can write the problem x to a power, I can use that rule. So let's think about 1 over x to the 5th. Can I rewrite that? X to what power? Negative 5, yes. Take the power now, which is what? Negative 5, move it to the front, and subtract 1 from the power. What is negative 5 minus 1? Negative 6. You got to subtract 1 from the power. And again, if you want to rewrite that, that's negative 5 over what? X to the 6. Rule number 3. So that's rule 2 here. Did I number them? Yeah, that's rule number 1 here. I wrote 1 there. This is rule number 2, the shortcut. Let's look at rule number 3. It says the derivative, if you have a constant, if you have a constant times f of x and you want to take the derivative of that, you can take that constant outside times the derivative of f of x. Again, I'll box that. So if I come in and I say, can you tell me what is the derivative of 5x cubed? What this rule is telling us, I can take the 5, move it to the front, and rewrite that as 5 times the derivative of what? Of x cubed. And what's that? 5 times. What's the derivative of x cubed? Yes, 3x squared. 5 times 3? 15x squared. Now, a lot of people don't want to keep writing this, so guess what? They go, never mind breaking it down like this. Just go 5 times 3, which is what? 15, subtract 1 from the power, and you end up right there in one step. So instead of doing these 2 steps in between, you can jump to the answer in one step. The derivative of 8x to the 6, if you don't want to do all these steps, what's 8 times 6? 48, and subtract 1 from the power. 5. Now remember the problem today we had that took 2 pages, the long way? What was it? 8 over the square root of x? Wasn't it? Okay, let's look at that one. The derivative of 8, the square root of x. That was the problem.
8 over square root.
Oh, 8 over. Yep, thank you. Let me just rewrite this one. 8 over the square root of x. We know the square root of x, x to what power? 1/2. But because it's in the bottom, that becomes what? 8x to what power? Negative 1/2. You agree with that one? Now, multiply these 2 numbers. What's 8 times a negative 12? I mean, 8 times a negative 1/2. I don't know where the 12 came from.
Negative 4.
Negative 4. x to what power? Subtract 1 from that. What's negative 1/2 minus 1?
Minus 3/2.
Negative 3/2. And your answer is negative 4 over x to the 3/2.
Do you think the other software would accept?
3/2?
Yeah.
They might. But if not, you can look at it negative 4. That's really the square root of x cubed. And the square root of x cubed, you can break it down to take 1x out, square root of x. And that was the answer we came up with. Notice in one line here. The derivative of 7 over x to the 3. I can write that as what? The derivative of 7x to what power? Negative 3, yes. Now let's take the derivative. 7 times the negative 3. You multiply these two numbers. 7 times the negative 3. Negative what? 21. And you subtract 1 from the exponent. What's minus 3 minus 1? Negative 4. In a minute, I'll start mixing problems together. Right now, I'm just going through the properties, the rules there. So that's the third rule of derivative. What about the fourth rule of derivative? It says if you have addition or subtractions, you can break it down, simplify it. The derivative of f of x plus or minus, doesn't matter if you have addition or subtractions. You can actually break it down to the derivative of the first one and if it's plus, stays plus. If it's minus, stays minus. The derivative of the second one. One of the questions we just did was f of x equals what? 15 minus x squared. Remember that one? That didn't take that much actual space in your notebook. But if we use the shortcut to that, as the derivative. What is the derivative of 15?
0.
0. Derivative of any constant is 0. There is the minus sign. What's the derivative no, I just gave you the answer. What's the derivative of x squared? 2x. So what's the answer? Negative 2x. So when you said to me, wow, you did that problem in your head? That's what I did. So I'm not that smart anymore, you know? We can do any combinations of these. I'll try different ones. Having fun, might as well put all the stuff in it. What is the derivative of that? What's the derivative of x cubed?
3x squared.
3x squared, yes. Here's the minus sign. Now let's look at that. What's the derivative of 4x squared? Just that one.
8x.
4 times 2, 8, and you subtract 1 from the power. 2 minus 1 is 1. You don't have to put the 1. What's the derivative 5x?
5.
Just 5, because the derivative, remember, this is a 1 here. 5 times 1 is 5. Subtract 1 from the power becomes 0. Minus, what's the derivative any constant?
0.
I don't have to write the minus 0 there. So when you write that, don't put the minus 0. You go 3x squared minus 8x plus the 5. I'll make my own. F of x equals 7x squared plus 3 over the cube root of x squared minus 6 over x to the square here. Not what I might do with this first, I'll do one step, rewrite this before I take the derivative. So I'm not taking the derivative yet. This will be 7x squared plus, I can rewrite, that's a cube root, not 2/3, I mean 3/3. That's a cube root. This will be 3x to what power? What is the cube root of x squared? X to the power 2/3. So always this one divided by that. The fact that's on the bottom, when you bring it to the top, negative 2/3. And this will be x to what power?
2/3.
No, before I take the derivative.
Oh, it's negative.
Negative 2 right now. You can't take the derivative of this and divide them, and the derivative of that, divide them. It doesn't work that way. So what's the derivative now? The first one, 7 times 2, 14, subtract 1 from the power. 2 minus 1 is 1. The next one, plus 3 times negative 2/3. Multiply these two numbers. If you multiply them, that's what? Negative 2, x to what power? Subtract 1 from that power. The 1 is what? 3 over 3. That becomes negative 5 over 3. And the next one, what's negative 6 times a negative 2? Positive 12, x to what power? Negative 3. You're always subtracting 1 from the power. Again, if they don't like negative exponents, they go, I got it now. That's 14x minus 2 over the cube root of x to the 5th plus 12 over x cubed. And if you want to simplify this, every 3 inside will give you 1 on the outside. Every 3 x's on the inside will give me 1 on the outside, because that's a cube root. And that's my final answer, simplified. They probably don't care if you write the answer with negative exponents, like this, like that, I'm not sure. We'll find out as you do the homework, which way they want it. Now, we're going to give you some shortcut, but those are actually now trig ones. So we have to know these. We have to memorize them. There is no other way to put it. I don't have a shortcut for you to help you memorize them. So you just got to put them in your memory. The derivative of sine of x is what? Anyone? How about positive cosine of x? And the derivative of cosine of x, that's a negative sine of x. Now, people said last time, why do we have to go through all this derivation, the 4-step? Why not just give us these and let us use them? Well, what about if I say prove that the derivative sine of x is cosine? I don't believe that's true here. I said, I disagree with that. Prove it to me. So how can I prove that the derivative of sine of x is cosine of x? So here we go, f of x. I'm going to do the math and show you that's why we looked at the 4-step process. It's sine of x, and I'm saying find the derivative of that. If I need to prove it, I have to use the 4-step process. The first step, I need to find f of x plus h, or delta x, whatever you want to call it. And that's sine of x plus h. And you better know some trig identities, and the good news, I have them on the board. See number 12? Sine alpha plus beta, you can break it down. It's right there on that board. To sine of x, you can break it down to sine of x, cosine h, plus cosine of x sine h, using rule number 12 on the board, trig there, sine alpha plus beta. Step number 2, subtract f of x from f of x plus h. So I'm going to subtract from that f of x, which is sine of x. The only thing I can do at this point is factor sine of x out of these two. If I factor sine of x out of these two, I'm going to have what? Sine of x times what? Cosine of h minus 1 plus cosine of x sine of h. So I took these two and I factor sine of x out of them. Step number 3, divide everything by h. Says dividing each one by h. So maybe I write them as two separate problems. This way I won't go cross-eyed looking at them. So when you divide the whole thing by h, like dividing each one of them by h. So I opted to go into two pieces, just to make it look a little bit smaller. Limits. Let me, so I can refresh your memory quickly. Where'd you go? Here we go. Now, take the limit as h approaches 0 of this one. Well, I can break it down to two problems. I can break it down to this one plus the limit of that. So it's the limit of sine of x cosine h minus 1 over h plus the limit as h approaches 0 cosine x sine of h over h. Notice here that the cosine of x does not have h in it, and the sine of x, there is no h in it. So these two, I can take them outside the limit because there's no h in them. So this becomes sine of x times the limit as h approaches 0 of cosine of h minus 1 over h plus cosine of x times the limit h approaches 0 sine h over h. I went through my book while we were doing this just now, and I looked for the special cases just in case you forgot about them. Here's the special case. The limit of sine of x over x as x approaches 0 is always what? 1. That's this piece. That's this one. The answer to this, that's a 1. Plus, what's the answer to this?
0.
That's a 0. The one in the book we have 1 minus cosine. Big deal. Multiply the top and the bottom by minus 1 and factor the minus 1 outside. So that is a 0. So what is sine of x times the 0? That's gone. So what's left there? Cosine x. That's the only way to prove that the derivative of sine of x is cosine of x, to go through the 4-step process. So somebody actually went through these and figured the math the way we're just doing it right now years ago and came up with a shortcut. So you want to memorize these two. You need to memorize them. You will not be given these on the test. What else you need to memorize? The derivative of e to the x. So I'll put it right there with this one while I have a space. Derivative of e to the x. Guess what the derivative of e to the x? Anyone? E to the x. So those three, take like a nice clean sheet of paper, write it on it, on the back side of your notebook, and keep looking at them, writing them down till you memorize them. I had a student one time, I looked at her hand, like, what the hell you have in your hand? Anytime we have one of these rules, she took a Sharpie and shortened her arm. And every time she looked, she goes, every time I turn my arm, I get to see it. It lasts about 2 or 3 days, wash in a shower, they eventually will go away. But by the time we finish, she memorized them all. She goes, my legs all have stuff on them. She writes the stuff all over her arms and legs and body. And that's her way to remember things. She's still alive, I guess she didn't die. You know? So maybe it is poisoning, but that's how she remembered them. She just wrote them down. Now, I told you earlier today I'm not a big fan of tattoos, but if you want to get a tattoo of these on it, I'll make an exception there.
come in, I can come in for the test with my tattoo. and
Yep,
then-
as long as you put it on the back of your neck, because you won't see it, everyone else will see it,
I get the tan line.
you know?
Oh, my God.
Yep,
Sine over cosine.
yep. Okay. So let's add more to these problems. What's the derivative? Combine some of these of 3e to the x.
It would be 3 e to the x.
Yes, because you can take the 3 outside times the derivative e to the x. And I just finished saying the derivative e to the x is what? E to the x. So 3 times e to the x. F of x equals x squared plus cosine of x plus 7. What's the derivative of that? What's the derivative of x squared?
2x.
2x, yes. What's the derivative cosine of x? Negative sine of x. Plus, what's the derivative 7?
0.
0, I don't need to write the 0. Okay, we get this problem. Seven e to the x. What's the derivative of 7e to the x? 7e to the x. The derivative of e to the x is e to the x. The 7 you can pull in the front. Here's the minus 3. What's the derivative of sine of x? Cosine of x. Here's the plus 4. What's the derivative of the cosine of x? Negative sine of x. There's the minus. What's the derivative of 8x to the 6? 8 times 6? 48. X to what power? 5. So if you clean that, I don't like the plus 4 minus sign. That looks silly. So I can rewrite that 7 e to the x minus 3 cosine x minus 4 sine of x minus 48 x to the 5th.
That's the answer.
That's it.
See, I have trouble figuring out where all this stuff. Just gonna keep going, that's all that.
Now, where we use calculus. Some of you probably went to register, especially if you're one of our students here. You want to take physics. We say you can't take physics till you finish calculus 1. Other schools, Holyoke and other places, you can take both calculus 1 physics at the same time. Well, the reason we don't want people actually to take both at the same time, because you need some of the stuff. You need calculus 1 to finish the problem. So for example, we know a projectile when you drop something, not even just free fall. Let's say somebody, here's a story. You're on top of a building. This is building 17. You manage to get on the roof. You're standing there. That's you. And you're holding a water balloon, not a rock. We don't want to kill anyone. The height of the building is 150 feet. and you see your calculus teacher coming out of the building, and you mad because you just had a test, didn't do well on it, and you threw the water balloon down, straight down here, with initial speed of, it's coming down, so it's -5, because down is negative, up is positive, feet per second.
Thank you.
Neglect the wind, friction here. The equation that described that, you don't have to know where we came up with the equation, is -16 t squared minus 5t plus 150. That's the height at any given time. So if you want to find the height, S is the height, or I can call it H. S sounds well, distance, I guess, I don't know. Let's call it S of t or H of t, the height as a function of time. So that's what that equation is. You want to know how high the ball is, or the water, what was it we said, water balloon? It wasn't like a rock, water balloon. How high is it after 1 second? At 0 second, if you let t equal 0, where are you standing? Top of the building, 150 feet high, right? So what's the height at 0? You let t be 0. It says it's 150 feet. We know that because you're sitting on the roof. Now, after 1 second, that'll be -16 times 1 squared minus 5 times 1 plus the 150. So what do we have? Is it 129? So we can find the height of that water balloon at any given time. We can calculate how long would it take to hit that person there. If the person is 6 feet tall, for example, you want to hit them on the head. If that person is 6 feet tall, okay, you can say, okay, let the height equal 6 and solve it for what? Solve it for the time. So now you can solve, when is that ball going to hit that teacher on the head? Because you know what the height is. But what about if I'm interested in the velocity, how fast the ball is moving? Someone said terminal velocity, we were talking about it. What is the speed of that water balloon coming down? What's the velocity at 1 second? What's the velocity at 2 seconds? Hopefully the ball is still moving at 2 seconds. How do we calculate velocity? Well, the velocity or the speed is the derivative of that. Is the derivative of the height, displacement. If you take the derivative of that, what's the derivative? -32t minus 5. So that's why you need the calculus to find the velocity. So what's the velocity after 1 second? How fast the ball is moving after 1 second? Or after 0 second, when you just dropped it? Well, you didn't drop it. You went like this, initial one. Has a 5 feet per second coming down. But at 1 second, the velocity is what? -32 times 1 minus 5, which is -37 feet per second. Negative means coming down. That's what the negative indicates. Downward. What's the velocity after 2 seconds? If you neglect the wind, the friction, that's -32 times 2 minus the 5. Now we start to pick up speed, which is what? 64, 69? So we can tell you the velocity of that water balloon or that object at any given time during that flight there. We can also tell you what the acceleration is. Acceleration is the derivative of the velocity. So take the derivative of that. What's the derivative of -32t? -32 minus what's the derivative of 5? Isn't gravity 32 feet per second squared?
I never learned it in feet per second.
It's always meters per second, 9.8 meters per second square. Huh?
I thought you said free fall. Oh, it was free fall, okay.
Well, once it leaves your hand, it becomes a free fall. You can throw it.
Yeah, I thought you free fall.
Even if you throw it, once it leaves your hand, the only thing acting on that, the only acceleration is gravity. It doesn't matter if you just let it go, throw it down, throw it up. Once it leaves your hand, the only thing acting for acceleration is gravity on it. If we neglect the friction. Obviously, if it's a piece of paper, you can't neglect the friction. Watch how slow the paper falls. Because the wind is like a parachute pushing up on it. But you take something heavy like this, and it doesn't matter if you throw it down, throw it up, once it leaves your hand, the only thing pulling down on it is gravity. And that's why the 32 feet per second square came in. So we use actually calculus and physics. That's one place for it. Make sure you know velocity is the derivative of displacement. S is displacement, the height. And acceleration is the derivative of the velocity. It's actually, the acceleration is called now also, it's called the second derivative of that. We'll get to that later, because you take in the second derivative. The derivative of the derivative is called the second derivative. Okay.